Good afternoon, everybody. Welcome back to our final session this afternoon. If you've been here since the beginning, then you've had a lot of information to process. We have one final session which continues the use case that were introduced in the previous session by Koen. And during this session, we're going to focus on the energy sector, the mining sector, and an example of private networks in factories. So I'm Peter Clemens. I introduced myself this morning during my session. So hopefully you know me by now. I'm a director and board member here at UINA. I'm joined on stage by Wavestone's Pierre Rinaldo. And we have online Eric Lheureux from Ambra and David Fontaine from Airbus. So you can both hear me online?
Very well. Can you hear us?
Yes. We can hear you as well. Perfect. So what we will do at the beginning, I will allow each of you to very briefly introduce yourselves, your organization, and discuss the relative use cases from your particular sector. And then at the end, we will go into a general discussion and Q&A. So I will now hand the floor to Pierre.
Thank you, Peter. So I'm Pierre Rinaldo. I'm a Wavestone consultant, and I'm really happy to be here today. I've heard a lot of interesting things this morning about technologies, public and private network interworking, satellites. Everything was really interesting, and I wanted to share with you some insights about what we do for our customers as a Wavestone consultant. So we're working for end users, large companies, empowering these technologies to unlock some new use cases. And I will discuss with you some use case in utilities and especially in smart grid, since I'm working for Enedis for now 6 years. Enedis is the unique DSO for France mainland, so they manage a large power grid infrastructure. And the power grid infrastructure is really distributed infrastructures across all and various territories. You can see here the figures. So it's more than 36 millions of customers. It means that much smart meters. And there's a lot of power lines, 1.4 millions. And if I talk about substations where you have some devices to be remotely connected, there is more than 100,000. And also Enedis is connecting all the new renewables energy providers. And it means photovoltaic or wind farms, and they have already connected 7,000 hundreds of them, and more is coming, like 100,000 more every year. So the networks needs to be there, and the networks needs to be to deal with these challenges. The thing that is great in the power grid is that telecom is really everywhere. It needs to connect all these devices, meters, remote control sensors, protection systems, but it also needs to connect the peoples that are in charge and that are maintaining the network, that are extended also the grid up to different territories. So we can find all telecommunication technologies there. There are also, of course, fixed networks for the more core parts, but there are also 2G, 3G, 4G. There is also IoT systems like LoRa or NB-IoT to connect small devices, but also satellites, VSAT and LEO solutions, and even private mobile network based on Tetra solutions. So with the transitions to smart grid, there is a big thing happening at Enedis, and for all, in fact, for all smart grid providers. They need to deal with renewable productions. They need to deal with intensifications of consumptions, and probably more and more storage into the grid. And this requires, in fact, to digitalize more and more devices within this power grid to make sure that the grid is still stable and also secure. This push the pressure onto the networks because these assets needs more reliable bandwidth and increased reliability. Also, it needs to become more agile. As I said, Enedis needs to connect 100,000 new renewable productions every year. So they need to connect them. By now, it means some fixed line connectivity, but now we are looking at wireless connectivity for them. So Enedis is used to leverage new and emerging technologies to improve, in fact, network capabilities and ease smart grid transitioning. In 2020, we launched with Enedis an open innovation program. It was named 5G 3E for exploring and experimenting 5G for Enedis. And since it is an open innovation program, we invited some partners, and we have Orange, Nokia, and Schneider in the place. And we also onboard 12 business new units of Enedis to invent some new use cases based on 5G that could help and that could be pertinent for Enedis. We cover many business lines from industrial control system, high voltage, low voltage, field maintenance. There was also supply chains, renewable and connections, and also services for EV charging that were implied in these projects. We end up with 60 use cases, so I will not present all those, but only the 6 of them that were awarded at the pitch contest and then experimented during 2 seasons that we've drove since then. So first use case, we have more focus on how to augment the frontline workers. So Enedis have a regional base of technicians that are used to maintain the network, and we use 5G to augment those field workers. For example, we had some vision augmented helmets that were connected through 5G to enable to augment the vision of the technicians with real-time information about the device or the assets that was in front of him, pushing real-time metrics, the current, for example, to make sure that he knows what is the system and in which condition is the system he is working on. He has also direct access to procedure and maintenance procedures, and also checklists to ease the work and make sure they do that safely. He also has the capabilities with other lighter glasses to share their vision to a remote expert, so that the expert can guide him into the current work that he's doing on the field. Second set of 2 use cases were to enable a more automated power grid inspections. So we managed to fly drones over high voltage lines to do the inspection. So that's mid-voltage lines. There is 300,000 kilometers of lines that Enedis should inspect every 1, 2, or 3 years. Currently, they do that with helicopters, and but they are moving that to drones, and so we tested drones with 5G devices onboarded, and managed to stream high-quality video, like 4K videos, through 5Gs to a control center, where we can see the images. Later, there will be some artificial intelligence that we could automatically detect some defects, and that defects being raised as an alarm could be then processed through a human that could directly double check if there is a real issue and what are the things that he will dispatch teams to handle these defects. We can also have robots on the substations. So high mid-voltage substations are large fields, open air fields, and we managed to have a robot connected in 5G rounding around this substation. It can do surveillance. It can perform also a maintenance inspection with 3D cameras and also with IR cameras to check whether there's some abnormal heat or things like that, and make sure that we have the right person that can then check that and perform some maintenance if required. Final set of the 2 use cases. It is about digitalizing the edge of the power grid. So when we connect new renewables productions, Enedis should implement some power protections for the grid. And it requires some low latency communications between the producer, the renewable producer, and the first substation. And this requires to be less than 50 milliseconds. And normally they do that with fixed wireless LAN. And we managed to move this system, this protection system, on 5G and reaching those requirements, which is a huge gap for them, because for the moment to connect a new renewable producer, it takes months, and with 5G they expect that to be much more simple and to be able to connect additional renewables in a really more agile way. Finally, on smart meters, so this is something that is currently done through IoT systems, but we also tested it in labs some LTE, M2, and 5G RedCap capabilities, because smart meters also requires more bandwidth. It's not only collecting some metrics every day, every hour. It's now having the capability to act on those smart meters to more control the power that is provided to the customers in order to be sure that we can equally share electricity power to everyone, even in case there is a high pressure on the grid. I will end up with a reflection that is currently happening with regard to the distributed environment of Enedis. So they usually rely on public networks, but we see that this is good, but it has also some difficulties. And the power grid and the telco networks has become more and more entangled, and it causes some issues when we talk about resiliency, because in case of major events, well, the power grid needs to recover and cannot rely only on public networks, but because we know that 10, 20 minutes after there is the major power issue, the surrounding 4G, 5G networks are out, and Enedis managed to recover without these public network capabilities. So that's why they are thinking about moving and implementing mobile private network, even at nationally wide. This is a kind of difficult project to launch. Enedis still have already power PMR network with 1,000 sites, radio sites. So that's something that's an asset that is useful. And they are currently using it for a critical voice to coordinate field technicians. But they want to improve and upgrade these to 4G and be able to connect remote control systems and enable to control them proactively, and also enabled to deploy some and control remotely some temporary power assets like power generators or substations. So that's all the thing that we can do with 5G and private mobile network for smart grid.
So clearly, as you mentioned, I mean, we saw in the previous session, we saw the ports, the airports, a little bit of logistics, and we're going to now move into like the mining and the factories. But when we're looking at electricity grids, it's very clear we are talking kind of nationwide, we're talking kind of very, very extensive coverage. So particularly in UINA, we talk a lot about the availability of spectrum. So I'm guessing you were saying that they're using at the moment a low VHF 70 megahertz
70
network.
megahertz.
So in order to implement a nationwide smart or kind of private 4G or 5G, they would need to have access to kind of UHF spectrum or something like this?
Yes, of course, we are thinking of 450 megahertz because this is something that is already used in neighboring countries. But also I was very interested this morning about private and public network interoperability, because I think that we need to have some kind of hybrid networks to cover that requirements.
Always important to have a backup, I guess, rather than
Exactly.
just one network. Okay, so thank you very much, Pierre, for that, for introducing Smart Grid and Energies. I'll now move to Eric from Ambra. I believe, although we won't be able to kind of present your slides kind of immediately during the session, but I'm guessing that we'll be able to make them available afterwards.
Sure.
And feel free to kind of use them to guide you through your presentation. So over to you, Eric.
Thanks a lot. So again, my name is Eric Lheureux, CEO of Telecom Engineers. Basically, Embrace Solution has been deploying private network for more than 10 years now. In Canada, we are a mobile network operator. We own Spectrum. But today we're now deploying networks in more than 10 different countries. We do, of course, a lot of minings, and this is what I'll explain today on that session. But in addition of a lot of other vertical market, the same need for all of those market is mission critical application. So as we've discussed today. We're agnostic, so we work with multiple RAN vendors, whether it's Ericsson, Nokia. We work with multiple core vendors as well. But in mining, that's interesting because we've been covering more than 75 mines. We deploy typically 10 to 20 new mines a year, so it's a lot. So private network is not only like a test, it's actually used in production. And today it's used to fully automate those mines. You can go to the next slide. Actually, I see that now there are some slides that we see. We've been working a lot with the OEM, with the machine builders, those Caterpillar, those Sandvik, those Komatsu, those Epiroc, that build those machines fully automated today. But they need a robust network, and that's where we come in. So that's where we basically we help those OEMs to deploy the network before they can sell those big machines to the end customers, the mining companies. So in terms of underground mine, we've been covering more than 800 kilometers of underground tunnels with our technology. You can go to the next slide if possible. And then in terms of in terms of basically number of radios, number of sites deployed, this is something which, as I mentioned, we keep deploying. So if you go to the next slide, the two big use cases that basically justify the investment over private 4G, 5G are remote control of machines and tracking. So what we do basically is we do a turnkey solution. We deployed and we do the engineering, the RF engineering, the IP engineering. We sometimes manufacture devices, as you'll see in the presentation. We provide 24/7 support because those mine they run 24/7, and they rely on the 4G, 5G network for day-to-day operation. So, as I mentioned, remote control and automation are the most important one, but we've been creating and patenting actually a solution to track in real time where are the workers, where are the assets in a mine for safety. If something happens, how can we quickly know where are the people? How can we quickly evacuate those mines? And this is used by a system using NB-IoT devices that we've been creating and combining multiple technologies. And today it's being deployed pretty much everywhere. So let's go to the next slide as well. So really the goal is to provide full coverage, whether it's an open pit, underground, in a port, along a rail, or in a process plant. So workers today are always connected. They can in real time talk to their supervisors, and those machines are remotely controlled from either above ground or from a remote site more and more, because a lot of those mines are remotely located. So flying people on site is expensive. Today, we see huge control room being built in large cities that remotely control machines that are 3 kilometers on the ground in a remote site. So this is what we build today. And those machines underground, they're used to operate initially between the day shift and the night shift. But now we see more and more mining companies remotely controlling machines at night and during the weekend. So there's no more people going underground during those periods, and everything is done remotely. So as you may imagine, the efficiency is going up, but also the safety of the workers. They don't have to go down anymore. They are relying on the 4G, 5G network to do those operations. So you can go to the next slide as well. So, so you can see here some pictures, and I'll show you as part of the presentation different pictures. But basically, once the remote control and the tracking is in place, the next use case is, of course, a push-to-talk. So those mines used to have like a UHF, VHF system with what we call leaky feeder, which typically has been designed to provide voice-only capabilities. Now with 4G, 5G, they rely on one single network, one single infrastructure, which is fully redundant, by the way, because we install 2 core on-premise, we install IMS, we install VoLTE, we install everything on premise. So they don't depend on any cloud component for the mission critical application. For the non-mission critical application, it can rely on the cloud, but for those specific use cases, everything is installed on premise, and to make sure as well that we reduce the latency for those use cases. Next slide. Actually, you can actually skip to the next one, basically. So as you can see, we've been manufacturing also devices. This is a cell on wheel, which most of you know, that is used mostly in open pit mining or with public safety, where you quickly need to deploy coverage. Mining, as opposed to the standard facilities, is a dynamic environment. They move mountains, they move rocks every day. So even though you do a nice RF propagation design, 2 weeks after is going to have to be redone. You'll have to redo it again. So this is why we have some. We've been building some component, and we've been establishing some engineering design to adapt. Make sure that there's no interference between the sectors. Make sure that we optimize the RF for the uplink speed, because all of those machines that are remotely operated, they all have cameras, so they're all uploading a lot of data. So most of the time, the download speed is fairly low compared to the upload speed. So this is what we need to design for. And then we have trailers or cell and wheels that we moved constantly in order to ensure that coverage. You can go to the next slide. So we don't see on that 2D, but it's actually a 3D system that we've been creating to track workers on the ground. So this is used in factory, in plant, and everywhere where there's no GPS coverage, basically. So this is what we do is basically we've been creating an ecosystem that range from any kind of modems up to a small chip that we put into the hard hat that have always connectivity, low power connectivity with NB-IoT or CADM, and that's how we can really connect those workers. So those workers are connected all the time. And then we have what we call wearables. So now we can track the gas quality around each worker. We can track the biometric, the anything which is temperature. We can do what's called men down detection. So if someone falls on the ground in an area, we'll quickly notice the other people so that we can get those people and rescue those people. We can also detect how many people are in a specific location. We do geofence, but let's say there's a refuge station with a maximum quantity of people that can fit in the refuge. So we'll check to make sure that there's no more than the maximum allowed. And also we'll notice and we'll help workers to find those safety gears. How many safety masks do I have in that location? How many extinguishers to the location? So there's a lot of safety component around what is being created for tracking people. And also what's important is those CAPLAM that those people have, you'll see some picture later, is we can have bi-directional communication. So we'll make those lamp flash in case of evacuation. We'll wait for the workers to acknowledge the evacuation. So we'll look for all of those workers to make sure that they are in a safe location. Let's go to the next. Then we've been manufacturing some devices. Of course, we use as much as possible off-the-shelf component thanks to 3GPP. That's the beauty of private 4G, 5G. There's multiple vendors that manufacture great devices. However, in mining, we have pretty harsh environment, and there was not really good IP67 5G devices that were designed for harsh environment, vibration, high temperature, and also what's important is to support legacy protocol. I'm sure you know, but a protocol like Profinet, Ethernet IP, Multicast, Broadcast, all layer 2 protocol. They're not by default compatible with a 4G, 5G network. So our UE allows to seamlessly connect those devices, so they don't have to switch to a layer 3 technology. We will still support any kind of VLANs, any kind of layer 2, any kind of Profinet, while keeping them in really low latency. So that UE also allows to do that. We call it layer 2 encapsulation. We have also a lot of features like redundant features. Like in 4G, there's only one antenna that transmit by default. Well, with that UE, we actually transmitted 2 antennas. So if one antenna fails, the other antenna will transmit. So there's a lot of fail-safe and redundancy in those kind of devices because those are mounted on those big machines, those heavy-duty machines, and those machines need to run 24/7. We cannot afford those machines to stop, basically. So that's an example of a UE that we manufacture. Let's go to the next slide. We also manufacture smaller UE for any kind of sensors, Modbus sensors, any kind of flow meter sensors. So those are gateways that will convert, let's say, Modbus TCP to Modbus RTU while having connectivity, GPS tracking, as well as any kind of telemetry for the engine. Let's say you want to know where are your engine or motors on the mine. Do we need to do the oil change after X amount of hours? So those systems will in real time monitors the vibration, the telemetry will be doing what's called proactive monitoring, and then we'll raise alarm so we can act before there's any failure basically on those machines. Next slide is I was mentioning about the workers. So this is an example of a connected workers where the actual chip that we manufactured is fitted into the CAPLAM in that case. So we're tapping into the existing battery without affecting the battery autonomy of the CAPLAM because we're using very low power technology, and we allow that CAPLAM to be connected and act as a gateway for those wearables that I was talking to. Next slide. We've been working, so those are example of OEMs that we've been working with. Caterpillar, they do manufacture a lot of machines, both trucks and loaders. So now you can see what it looks like a control room to remotely control those loaders. If you go to the next slide, we've been working with Sandvik, which they are based in Finland. Sandvik, they have loaders that can be remotely controlled, but it's interesting, they have autonomous trucks. So those trucks, they have no drivers. You just push a button and the trucks will automatically go out, dump, and comes back automatically. So the trucks needs constant connectivity, of course, for the control, but also is equipped with what we call LiDAR to know where the truck is located in real time as well. So those are examples of technologies that we have to work with in order to ensure reliability. And so far, that's been deployed to multiple mines. So we have a lot of projects that they rely on that technology to be efficient today. Next slide. We work with a company called Epiroc. Epiroc, they do manufacture drills that are installed in open pit mines. So again, we remotely control those drills. And drills, the process of drilling a hole may take hours and hours. So how it works is typically we'll have a remote control room with a ratio of 1:3. So 3 drills for 1 remote control. One controller. So that guy will operate the drill, will start a process like a drilling pattern, and then the drill will start its process, and then he's going to remotely control a second one and a third one, and so on. So those are things, and those drills are equipped with high definition video. So this is important for those drills to have enough bandwidth to see what's happening around the drills, basically. Next one is the air sensing. Mining can sometimes be quite challenging in terms of air quality. Up to now, gas sensors were fixed, located on walls and so on. Today, thanks to our technology, we can now in 3D show where there's good gas, where there's bad gas, because now every worker becomes a scanner. Or we have what we call portable air sensors that are all connected over 4G, 5G. So those are things that up to now were not possible. Up to now, the guy in the morning were having like gas sensors that was recording, and at the end of the shift was downloading the data, but there was no geo-reference of where it was exposed, where were the bad gas. So now in 3D, we can map in 3D with a color code where there's good gas or bad gas. Next slide is the remote blasting. So now we blast over LTE. So that's basically with multiple companies. So you don't have to be close to the danger area. So that can be remote. And then the last slide is remote sensors. So we can remotely detect any kind of vibration in the ground or any kind of flow meter for how much air is being pushed in the tunnels. So those are examples of some use cases. There's way more use cases, but those are the most popular ones that we use in the mining. So that was, I wanted to try to squeeze this as much as I can. Feel free to ask a question at the end if you want. Thanks a lot.
Interesting catalog. No, because normally we just see devices, networks, but you have integrated a large number of devices as well. So what's important, I get, it's the customization. So private networks, each sector, there's some commonality between the different sectors, but at the same time, there is a lot of customization needed. So I guess a company like kind of Ambra and also kind of Wavestone, you have that kind of deep knowledge and that speciality within that particular sector that it would be much harder for maybe other companies that are dedicated to kind of much more kind of general use cases, I guess. And also what's...
Well, exactly. We see CSP trying to cover network, but CSP don't have that knowledge, don't have the knowledge of the industry. So this is the edge that we have compared to a standard MNO or CSP.
And the importance of safety as well in these sectors. So smart grids, mining, I know I visited a lot of mines kind of working as a consultant in Latin America, and number one was 300 days since last accident, etc., and they want that to go kind of higher and higher. So safety is kind of absolutely key.
Yes.
Okay, thank you very much, Eric, for that. We had some... We ended up with some nice pictures that I wasn't expecting, so that's good. Now we go, a company that we know very well is Airbus, particularly my background within public safety and mission critical. Clearly Airbus is one of the references for nationwide tetrapole networks, public safety, etc. But I guess, David, you also kind of make aeroplanes as well, and you have factories, so... can you please very briefly introduce yourself and then explain to us what you're doing in the area of private networks?
Sure. Peter, thanks a lot, first of all, to you, Ina, for inviting Airbus and myself to this very interesting event. So, yes, a little bit about myself. My name is David Fontan. Been working in Ericsson since 2018. I had a previous life in Ericsson. I belong, as Peter was saying, to the public safety and security area, which is a program unit of the Connected Intelligence business line. And this is all part of the division Airbus Defence and Space. Okay. My role is Sales and Business Development Manager in Region Europe. So I'm pretty much focused on the European countries. Okay. That's about myself and about the company. Sure, I'm not in the airplanes manufacturing part. Sure, much more related to the telco and to the critical commerce area, as you well know, Peter. Yeah. So entering into bringing some insights to the community here, trying to elaborate a little bit different to what has been said, which is a big challenge because being almost one of the last to speak is not easy in this sense, but I will try my best. I want to talk about an industry use case. Okay, I'm not disclosing the specific name by now. I'm going to talk before that about I would say generic topics, but I think that are relevant to this case, but to some other cases that any of us could have in front of us with different customers and especially industry customers. Okay, that's why I'm going to talk first of all about the challenges, the technical requirements, and the value proposal that we've encountered in this specific case, or I would say cases, because I'm not going to speak about a specific case, but say several cases in the same basket. Okay, but I think these are pretty much common to all of them, and I think when you hear me speaking, most of you will agree. So if we go to the challenges that we encounter when we face this type of cases, one of them is automation of critical tasks to minimize failure points. So doing things in the old way can bring you to failures, and we want to avoid that. Of course, as always, increase operational efficiency. And also in our world, that means coordination and teams collaboration. For that, we need to put some tools for our end users and customers related to advanced secure communication capabilities. Voice, data, video, evolved compared to what we used to have in the PMR world. Okay. And last but not least, a big challenge in the projects that we encounter is worker safety. How do we secure that the people work in a safer way? I mean, we are talking about, you've been talking before about mines. We talk about myself, I'm thinking about energy parks, industrial sites. These are dangerous places. So, the employees will for sure appreciate that we provide them with tools and means that makes their work safer. Second topic, technical customer requirements. Well, as always, customer wants everything, and we are here to try to provide as much as possible of that everything. First of all, for sure, improve network coverage and QoS. I mean, if I have the same thing that I used to have with the previous networks, then why to go for these private networks or this type of evolution, broadband evolution? Robust architectures with high redundancy, with a lot of nines. Communications are critical and cannot fail in this sense. Okay. In some cases, interoperation with existing PMR deployments. We in the critical communications world, those of us that are working a lot with the broadband evolution, have customers that are not 100% sure yet if they want to remove the existing PMR deployments. So we need, for those of them, to have some possibilities to interoperate, at least for some time, with those networks. For sure, MCX services, integration with the customer mobile device management system. We have to encounter also reluctancy to change. I mean, some employees have ways of working for many, many years and are not that eager to change. So we have to work with that. Smartphones, accessories, for example, the cases I will talk about, ATEX certified devices, working in high noise environments. So how do we cope with all of that? And to cope with all of that, I would go to the third bullet that I was mentioning to you that is generic before entering into the real use cases, which is the value proposal. And for me, this is very interesting because even if it's something that we have heard a lot now, for me, it's still a key success factor, the end-to-end approach. What we have found is that if we go in an isolated system, isolated application way, then chances of failure go higher. If we go on an end-to-end approach, chances of succeeding are much higher. And what does it mean? It means that we take care, of course, of the private networks, including the frequencies topics. We look about the end user devices, about the architecture, about the MDM, the applications, the deployment, the testing, but also about the users. And that's why we are also incorporating in our offering the change management part of the story. You know, workshops with the end users to try to accompany them in this transition, which is not easy. I mean, it's important technological change for everybody. And if we talk about the end users that have been doing things in a specific manner for many, many years, it's even more tricky, more challenging. Okay, 24/7 support and eventually operations. So let's not forget about the end-to-end approach, as I said, even if it's a very sometimes marketing world, a buzzword, whatever you want to call it. But if you look into the messages that I was trying to convey here, you will agree with me that they are relevant. Okay, and that will be somehow setting the scene. Then entering the specific use cases. Okay, I'm going to talk about a use case or a bunch of use cases, as I said before, that we are working and we are collaborating together with some customers in the energy sector, which is in the digital industrial workplace environment. That means digitalizing the workplace. Normally, this is part of digital transformation programs. This is part of going more efficiency, operationally speaking, evolving the PMR networks, having the smart connected worker at industrial sites, providing them with secure critical communications in those energy parks, or it doesn't matter, can be also any other type of, I think it's for sure valid for mining, for sure valid for any type of factory. Again, increase people safety, you know, SOS button, man down, proper control center to handle all that. And for sure, improve the team collaboration, leveraging the MCPTT, the MC data, MC video, and the geolocation capabilities. Okay. What we need for, what we have needed for running this type of use cases with this type of customers? Well, for sure, typically a private LTE or private 5G deployment, smartphones, well-selected ones. Normally, as I said before, if we're talking about energy parks, ATEX, very, very challenging topic to deal with these devices that have to work in environments higher than 110 dBs of noise. So you have to make sure that your applications, your ecosystem works in that environment, which is not tricky, which is not, sorry, taken for granted. It's tricky. RSM, external cameras, proper control center to handle the teams, to handle the communications. So we need all of that, okay? Then I will also talk about the innovation part where we are working with connected vests with sensors to monitor vital parameters from the control centers so that we can make smarter decisions in the field, okay? All the way to also drone for smart inspection and so on. So for the use cases that itself, okay, all the way from the traditional collaboration where we assign, for example, field users specific tasks based on the position that they have, not on who they are, but where they are. For example, in order to repair a mixed functioning machine like a turbine or something like this. Of course, this guy can also do coordination with the other members of the team, can be secure with different emergency capabilities by calls or alerts if he's in trouble. And as I said before, when it comes to innovation and evolution, eventually he can request remote assistance by, for example, communicating and sharing a video with a remote expert so that he can receive instructions on how to solve the issue if he's not able to solve it by his own, okay? Okay, he can also for sure fill in an incident report. He can, interesting topic, we can record the different missions, to to call it like that in the public safety world, so that we want to, let's say, later in time, do some time of forensic assessment or even training purposes. Okay. Indoor positioning. Okay, we are, as I said, in terms of innovation, incorporating different capabilities. To finalize, benefits from this type of use cases. Okay, remember, smart connected worker or the digital workplace. As I said, employees in the field feel safer. Very important to make them feel more safe when they do the work. Second one, increase productivity. I mean, if we are talking about having people well coordinated, having a remote expert, then we are reducing time to repair, and that way we are increasing productivity for sure. More sustainable operations. So with this type of remote assistance, we reduce travel costs and these type of things. As I said before, with the possibility to record the missions, the post-mortem, the training. And last but not least, having the image of being innovative and have a platform ready to deploy new use cases that is not only somehow stuck to the pure communication use cases, but we can go further. And in a nutshell, this is the main messages I wanted to convey to you. I'm happy to listen to any question.
David, it's never easy being the last speaker, particularly after so much information that's been shared throughout the day. So I think you did a fantastic job there. Thank you very much to all of the speakers. We have a question that I think is directed towards Pierre, and I think I was hinting at, and we were hinting at towards the end of that, and I think Justa has already left, but he would know exactly whether. So it says here, is Enedis looking at 450 megahertz solutions like 450 Connect in Germany? And he seems to know that Enedis is not a member of the 450 Alliance. So.
Well, that's true. Enedis is not a member of the alliance, but yes, the topic is on the table. This is something that is currently under study. There's no project yet, but still, that's some path that we want to closely study.
Okay. Do we have any more questions? Otherwise, I'll find a way of. Here we go. Yes, we do. And Thierry, okay, sitting at the back. 3 questions, so not even one now. So, Eric, you've got 3 questions. For NB-IoT devices, which frequencies are supported? Is mesh capability missing or needed? Do you need to interconnect NB-IoT to the 5G core rather than the EPC?
All right, let's go with the first one. For NB-IoT devices, as you know, Cat-M1 NB-IoT is supported up to band 66, so it's not possible to do this with higher frequencies like TDD. So that's one limitation. So frequency will be anywhere from 600 megahertz up to, I will say, 2.1 gigahertz. That's for the NB-IoT and Cat-M1. There's recently a new Cat-1 BIS that will include band 7 and band 41 that just been issued on the market, but still there's no yet low power devices that supports like 3.5, 3.9 or those 5G. So that was related to the third question, is there any low power devices for 5G? There's no ecosystem yet. There's no chip, low power or the equivalent of Cat-M1 on 5G yet. So that's a big limitation that we hope there's going to be some manufacturer that eventually will produce those kind of chipset. And then for the last question about the mesh, no, of course there's a V2X. There's some technology out there using 5.X. However, we haven't seen good, reliable mesh system in 4G, 5G. So but the fact that we install everything fully redundant, 2 core on premise, we don't really need the mesh in our case. So we design everything to be connected to that eNodeB. And keep in mind that when you start using mesh, you no longer have access to QoS. You cannot guarantee bandwidth over the air because now you rely on multiple devices. So reserving bandwidth for a specific application or ensuring that the latency is less, let's say, than 50 milliseconds will be challenging with a mesh. So which right now we can guarantee those SLAs with the system that we provide.
Okay, thank you, Eric. Any final questions?
Welcome.
Okay, so thank you very much to Pierre, to Eric, and to David. Thanks to everybody who's stayed until the very end of a long day. I hope you learned a lot from today, and I believe that our illustrious chairman, Christian, has some final words for you.
Thank you, Peter. Please, this is the moderator. You can come. Thank you very much, everyone. Thank you, the moderators. Thank you, Pierre also. We're really happy for this first event from Arena about this big subject. I think interesting subject. I hope that it was interesting for you, the attendees of this event during this 6th panel. I want to thank big thanks also to the speakers, a lot of speakers. Maybe I hope that you saw all of the speakers. The organization on Marie-Astrid Berry for the coordination on your patience. Thank you very much. Yes, just one word after that. We will put on your website all of the video of each panels. Don't hesitate to come to our website to take and to see the video, maybe not today, but maybe in the next days. It's really what we want to do also, to give the opportunity for some other people, other industries to see the video. It's for me finished. Thank you again. Yes, on the presentation also. Yes, thank you. Yes. After improvement, there will be also all of the presentation on our website. Thank you again. Have a nice evening and see you maybe later. Thank you. Bye-bye. Bye.